In this session, we are going to talk about the square roots of the given number. Now, when we are finding out the square roots of a given number, the very first thing that comes to the mind of a learner is what is the length of the digits. I mean, when I talk about the length of the digits, what I want to convey basically is what is, the number, the square root of which is supposed to be calculated by me here refers to a learner. Is it a one-digit number? Is it a double-digit number? Is it a triple-digit number? Or what is the length of the digits or the length of the number of digits in the given number? The second thing which a learner is curious to know is what is the concept that is supposed to be used. This is generally what the tendency is. But as a learner, if I am there in your place, the very first anxiety which will come to my mind is what is the concept that I'm supposed to use when I'm finding out the square root of a given number. I will not be much concerned about the length of the number or the number of digits in the number. The concept is more important than the length of the number. And second, then I would want to see what is the length of the number. So when we talk about the concept behind the number, a learner would be appeased to some extent because the concept is nothing but Euclid's algorithm of division, which is dividend is equal to divisor into quotient plus the remainder. Now, incidentally, when I'm finding out the square root of a number, the divisor and the quotient, I am taking it as a small d. So in that case, the dividend, which is a capital D here, becomes equal to a d into d plus r, where r is the remainder of this division, which eventually can be written as d square plus r. Now, one thing which we need to remember here is, which is nothing but it is an outcome of Euclid's division process only, is that the remainder will always lie from a 0 to a d minus 1. For example, if I am dividing a number by 4, what are the remainder possibilities? There will be 4 remainder possibilities, and the 4 remainder possibilities could be, when I am dividing a number by 4, the remainder may be a 0, maybe a 1, or 2, or 3. The remainder cannot be a 4. Please make a note of this. And incidentally, I am talking about this here is because we need to be clear with the basic concept, and the concept is Euclid's method of division. It is then only that you can use this Euclid's division method in finding out the square root of a given number. Right? Okay, now let's move on to the next step. Now, when we are talking about the next step here, I am taking a 2-digit number, and the 2-digit number that I have taken here is a 10. So let us go stepwise, and as I am going stepwise, I can see that 10 is a double-digit number which I have taken here, and then I am interested in finding out the square root of this number 3 decimal digits. So you would see that I have written the number 10 followed by 00, followed by another 00, and followed by another 00. Now, why have I made pairs? So the very first thing that I need to understand as a learner here is, when I'm finding out the square root of any number, I need to write down them in pairs. For example, 10 itself is a pair of digits. So you would see that I have put a bar on top of it. The next bar that I have put here is above a pair of zeros, then another pair of zeros, and then the third pair of zeros. Once you have done this, now you have to follow the Euclid's division process only, which says, now dividend, which incidentally here is a 10, so I need to identify a closest d square to the dividend. So if you are writing 3 as the divisor, the quotient also is the divisor in this case, because we are finding out the square root of the given number. Now in that case, you would see that 3 into 3 is a 9, and then the remainder here is 1. So in the first process of Euclid's division, while finding out the square root of a given number, you will see that 10 is the dividend, 3 into 3, 9 is the interim dividend that you get here. Now, what is the remainder here? D minus divisor into the quotient, which is d square coming closest to the dividend, which I am calling it as an interim dividend, and then you subtract from it to get an interim remainder. and the interim remainder that you get here is 1. Now as we perform, so you would see that now analogously, I have taken another example also there analogously, and I'm discussing the first step in both the cases. So you will see that I have taken a 3-digit number, which is 841. Now 841, I'm interested in finding out the square root of this number till 2 decimal digits. So in that case, I have taken 2 pairs of zeros, and then 841 I have prefixed a 0 because I know that I need to form the pairs of the digits that appear in the number, the square root of which has to be found out. So incidentally, in this case, if I have a 3-digit number, I have to make it a 4-digit number. If I have a 1-digit number, I have to make it into a 2-digit number, etc. is what I'm supposed to do. So we performed the first step in both the cases. So now let's come back. And as I come back to the given number, you will see that the first interim remainder that I had got was 1. Now I bring forth the 00 there. So once I have brought forth the 00, I put the decimal point as a part of the question that I get. So now the second thing that I'm supposed to do here is the units digit. If you would see in the first division, you would see that I have written that it has to be multiplied with a 2. Why have I done this? Because we know that a plus b whole square is equal to a square followed by a 2ab followed by a b square. So now in that case, 3, which was the first divisor, has to be multiplied by a 2 to get the first digit of the second divisor. And the second divisor, the second digit of the second divisor would be the same as the first step that we had performed. I mean, whatever number you are going to write down, you would see that I have taken a dash beneath a number, which I'm symbolizing as a units digit. So what do I need to write there such that 60, let's say 6 dash has to be multiplied by a dash such that it comes closest to 100. So 61 multiplied by a 1 will give me 61, and which gives me a second interim remainder as a 39. Now the 2 zeros, which is and the second pair of zeros, have to be brought down, and then I need to see that the second divisor that I had, which was 61, what is the units digit of the second divisor? Is 1. Multiply it by a 2 and bring it down, and the remaining digits come down as it is. For example, 61, the 6 in the 61 comes down as 6, but since 1 was the units digit of this second divisor, it has to be multiplied by a 2. Now the third divisor that I'm getting here is a 6 followed by a 2 followed by a dash. Now that dash has to be filled up by a digit in such a way that the same digit has to be written in the question's place. So you have to be very vigilant while you're performing this division. And just to give you a tip here, you would see that in 620 dash, the hundreds digit 6 gives you a fair enough idea of what needs to be multiplied or put in the units slot of this 620 dash such that it comes closest to 39 of 3900. So which is why you'll get a faint hint that 62 dash, the place, the digit which has to occupy the dash here is 6. Once you have done this, now talking about the fourth divisor here. So 600, the hundreds digit 6 comes down as it is. The 2 would have also come down as it is. But when I multiply the units digit of 626, which is a 2, which is a 6 in this case, then it makes it 12. Now when it becomes 12, now the tens digit of 12, which is 1, gets carried over onto the tens place, which is 2. So 2 plus 1 makes it 3. So you would see 626 becomes 632 followed by a dash. And now, as we had discussed earlier, the the thousands placed digit here in the fourth divisor is a 6, which if multiplied by a 2 should give me a number closest to 14 in 14400. I hope you understood this process, and the more you practice this, the more you will want to take it to its logical conclusion. Now here 10 is not a perfect square. The second example that I have taken here is an example of a perfect square, wherein we are performing the same operation as we did earlier, which is 2 into 2 is a 4. So I'm not talking about how do you make pairs, because the very first thing that you need to do while you're finding out the square root is that you need to make pairs. Once you have done that, then you need to identify the value of d square, or you need to identify the value of d such that d square comes closest to the first dividend, and the first dividend here is 8. So you can't take 3 into 3, which is a 9, because in that case it becomes greater than an 8. So all you do here is 2 into 2 is a 4, you get a remainder as 4. Once you get this, for the second divisor, the units digit of the first divisor was a 2, which needs to be multiplied by a 2 again. What is the logic behind this? We know that a plus b whole square is nothing but a square followed by a 2ab followed by a b square, is what we have done. Once you would have done that, now you get a 2-digit second divisor, which is of the format 4 dash. Now you need to identify which digit needs to be occupied in the place of a dash, such that the same digit has to be written above. Above here means in the place of a question. So in that case, as discussed in the earlier example, now if I see what is the second dividend that I get here, the second dividend that I am getting here is 441. Now the 44 in 441 decides which digit needs to be multiplied with the 10th digit of the second divisor, which is 4, which makes the second divisor multiple of the second divisor come closest to the second dividend, which is 441. So you get a faint idea, which is if I multiply 4 with a 9, it's a 36. So 36 comes closest to a 44. In that case, now I need to perform this division, which is 49 into 9, which gives me a 441. I hope you understood this, and you will be able to take this discussion to the next level. And the next level here is take examples on your own, and the best way to start off is start off with a single digit number and find out the square root of a single digit number till 2 places. And the second example that you could have taken here is a single digit number which is not a perfect square, and you are supposed to find out the square root of the given number till 3 decimal places, and then you can increase the difficulty level when you keep on taking it to the next level. Now, as advised, we would start off taking an example of a single digit number which is not a perfect square. Now, which in this case I am going to take it as 8. Now, why am I taking it as an 8? I am taking it as an 8 because I know that 8 is not a perfect square. And as advised, what we are going to do here is we are going to find out the square root of 8 till 2 decimal places. Now 8 is a single digit number. As discussed, we will make it a pair of digit, and the best way of making it as a pair of digit here is I can prefix a 0 here. So once I have prefixed a 0, now you would see that I have 3 pairs of digits. So in total, if I forget the decimal point in between, which is this, if I neglect the decimal point in between, how many pairs of digits do I have? I have 3 pairs of digits, which result into 6 digits in total. Now, what is the first step I'm supposed to do? I am supposed to take a number here such that the same number has to be written here. Now, when I'm taking a number here, the same number has to be written here. So, which in this case cannot be a 3 into 3. So, it has to be a 2 into 2. Which I, just for the sake of understanding, I am writing it as 04. Once I have written it as a 04, I know I need to subtract this, and I am getting what? 4. Now 4 followed by this should come down as it is, Now in order to make it come down, I need to put a decimal point here. Once I have put the decimal point, I can borrow these pair of digits, the pair of zeros here, to perform the second division. And as discussed, the second divisor, now the first divisor was 2 and the first question was 2 again, question. The second divisor here would be nothing but the units digit of the first divisor has to be multiplied with a 2 or by a 2. In that case, we get the first digit of the second divisor followed by a dash. So now whatever you have written here in the dash, the same digit needs to be written here as the question. So you will get a fair enough idea with the help of this 4 and the 40 here in the second dividend, which is 4 into 9. So can I put a 9 here? Of course I can put a 9 here, and I can put a 9 here as well. Once I have done this, 9 into 9 is 1, followed by 9 into 4 is 36. 36 plus 8 makes it a 441. So you will have a fair enough understanding that you cannot take a 9 here, and you need to take a number which is, or you need to take a digit which is lesser than 9, which in this case is 8. So once you have taken this, this is what you are going to get. You subtract and you get it as 16. Now these zeros are to be taken down as it is. So which makes the third dividend as a 1600. The third dividend as 1600. Now this 4 comes down as it is, right? And this 8 needs to be multiplied by a 2, which in this case is a 16. Keep in mind that this 1 now needs to be carried over here. Now, so in that case, 4, which was the first digit, does not remain as a 4, and it becomes what? It becomes a 5. That is, you need to understand. Once you have done this, and now the process still remains the same. In order to find out the units digit, you do the same speculation as advised earlier, on the basis of which you will be able to say what I am writing down. But the moment you write this down, you will come to know that the interim dividend that you get here is a number which is greater than 1600. So you'll have to go back again. So once you go back, you will see that you are supposed to write down a 2 here, which now in this case is the solicited units digit which was required. So which in this case now becomes a 4. Now the only thing I may be interested, I will not waste my time in trying to find out what the remainder is. All I need to understand here is whatever remainder I get here, this remainder should be lesser than 562, which it is. So you will be able to say that the square root of 8 is 2.82 approximately. Last but not the least, I am giving you a take home here, and the take home here is, please find out the square root of 8 till 3 digits, 3 decimal digits. This is one that you would do. Second, what is the largest double digit number, the square root of which you can calculate is 99. What is the largest 3-digit number, or let's say a smallest 3-digit number, the square root of which you can calculate? Let me take a smallest 4-digit number. Please find out the square root of this. So incidentally, what I meant to say here was, please find out the square root of 99. Hope you understood whatever was explained in this session. So please take your learnings to a next level by practicing it as much as possible.